Hello students, welcome to AcadShala.
Today we are going to start again part 3, the chapter Gravitation. Again I told you before also in previous videos that the whole chapter revolves around what, children? That is this formula, that is F is equal to G m1 m2 upon r square. So please keep it in mind, this formula which plays a very vital role in the numericals.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
Universal law of gravitation, that is ULG, Universal Law of Gravitation. This is the weakest among all, but it is still very useful for us. Now children, based on this topic, numericals are very important. So these kind of numericals which I am going to do in this session do come in the exams. They do come in the Olympiads where you participate in your school, NTSE exams, or in other competitions too. So this is the base, and you should also understand the language of the numerical which plays a vital role, that is the language part, and then implementing by reading the numerical into the solving of it. That is very important to solve, but you have to keep it in mind that how to solve. That means you have to be very good in calculation, your math subject. So calculation also plays a vital role in solving the numericals in time. So time management also, children, you need to understand very well. So with this good start, let us do the first numerical. It says, how does the force of gravitation between two objects change when the distance between them is reduced to half? That means this numerical again revolves around what? That is this formula only. But you have to keep it in mind, you have to see the language of the numerical, what it says. And according to the numerical, please keep on doing and then solve it further. Now what I will do? I will take two objects. See, I have taken. And what does it say? That this is m1 mass and this is m2 mass and this is the distance between the two masses. This though we know it very well. And now what happens? That we know the formula, that is F is equal to G m1 m2 upon r square. Now what I will do? I will write this formula over here and I will give this equation 1. That is, I will give the number to this equation as 1. Now what I will do? I will take another force, that is a new force. This was my old force, but something changed in this, that is between the two masses or the distance according to the language of the numerical. After changing it, that is a new force is formed. So what did I change in this? That is the distance between them is reduced to half. So what I will do? Instead of r, I will write r upon 2. So this is what I've shown over here. I have done the changes in it. So what will be my expression for the new force over here? That is, I will put it with the indication as F dash is equal to G m1 m2 upon r upon 2, which I have reduced to half, but do not forget to put whole square, which is really very important. Am I clear? Again I repeat, please do not forget to put whole square because this plays a vital role in calculation, otherwise your calculation will be wrong, children. Okay, after this, let us solve further. That is f dash is equal to g m1 m2 upon, then again solve it, r square I have written, 2 2s are 4, 2 2s are 4 I have written. I have solved further over here also. After this, I will solve further more over here. See it over here, children. So, what it is? That is, after solving further, I get this expression as 4g m1 m2 upon r square. So, this is the second equation according to me. So, this is the first equation. This is the second equation. Now, what do we do? Now I will divide the second equation by first equation. Okay, let me do it. So that is the new force which I have given the name as F dash upon F. This is the old force. And then I will quote the values accordingly. I've quoted the values over here. After solving all this, I get in the last as that is F dash is equal to 4F. So according to the numerical, what I got it was f dash is equal to 4f. Now what does it mean then? That means you have to write it in words also. Whatever you have taken out according to the expression given in the numerical, after you have finally done with the expression over here, f dash is equal to 4f. Now I will write it in words over here. That is, it goes like this. After reducing the distance to half of its previous value, the force becomes 4 times the previous value. This is what I have shown over here, and then I have put it in these words to give the final look of the numerical. So this is the way the numerical is done. And this type of numerical usually is asked in the exam, in Olympiads, in competitions, NTSE exams, and many more. So this is the base, the major and the root of the numerical, which you have to keep it in mind that what does the language says, accordingly change and then take out the answer. Okay, next. What happens to the force between the objects if the mass of one object is doubled, okay, the distance between the object is doubled and tripled, okay, the masses of both objects are doubled? Fine. Let us do the A part first. I have shown the two masses, that is of the objects A and B, and the distance between the two R. So the diagram is in front of you. Now after this I will put the expression over here. F is equal to G M, this one, small m, this one, and upon R square. Okay, I have written it. Now what I have to do? The mass of one object is doubled. Okay, one mass has to be doubled. So what I will do according to the demand of the question, G into 2m and small m will remain like that upon R square. So this expression I have changed according to the numerical demand. I've done that. Let me solve further. So 2 I will take it outside and then g m into small m upon R square. So this is the final expression I got according to the demand of the numerical. Now what does this expression say? I will put it in words. That is, force will become 2 times. Finished. That means whatever is the demand in the numerical, you will solve it, get the final expression, put it in words, and this is the final touch of the numerical. Okay. Next, B part says, what happens to the force between the objects if the distance between the object is doubled and tripled? Okay, first in the B part, I will solve for double first. I will focus on double first and then triple afterwards. Okay, let us do this. Again, I've shown you the two objects AB with masses m and small m with the distance r. After this, I will write down the expression. I know it very well. That is F is equal to G m small m upon R square. Now, according to the demand of this numerical, what does it say? I have to double. That means what? That is the distance between the object. So, what it is? So, this is the distance which I am seeing over here. So, I will double it. So, I have doubled the distance over here. So, I changed my expression from this to this. After doing the doubling of this distance, the expression comes like this. G m small m upon, calculate please, 4r square. Yes, I got it. I will put 1 upon 4 outside and then the rest of the expression over there. So that is 1 upon 4 g m small m upon r square. So I have got my final expression according to the demand of the numerical in it after doubling the distance between the objects, and after getting my final expression, I will put it in words as force will become 1 upon 4 times. Finished. Okay, let me do the B part, this tripled one. Okay, let's get started. Again, I've put two objects A, B with masses m, small m with the distance r. I know the expression I've put up. F is equal to G m, small m upon r square according to the demand of the numerical as given over here for tripled. That is tripled what? That is the distance between the two objects is tripled. So what I've done it according to the demand of the numerical, I have put up here the distance as triple. So this is the way I've done it. After putting it the expression according to the demand of the numerical, I have solved further. That is G m small m upon 3 3s are 9. I have written 9 and then r square. So r square. So 9r square I got it after solving. After this, I will put outside 1 upon 9 and then the rest of the expression G m small m upon r square. So this is my final expression according to the demand of the numerical of the B part, that is the tripled part. So after getting my final expression, I will put it in words, that is force will become 1 upon 9 times. So this is my final answer of this numerical. Okay, the last one, that is the C part. What happens to the force between the objects if the masses of both objects are doubled? Okay, now I have to double the masses. Okay, what I've done, again the same thing. I have kept these two objects A, B with the mass m and small m with the distance r over here as shown on the screen. I know the expression of force. I have written F is equal to G m small m upon r square. After this, I will see what is the demand in the numerical. What I will do accordingly, the demand of the question, I will change my expression. So how? That is, I have to, what I have to do it? The masses of both objects are doubled. That means I have to double both the masses. That is m also and small m also. Okay, so I will change the expression. So G, that is 2m into 2 small m. I changed according to the demand in the numerical upon r square. Okay, now again I will solve further. So that is G into 2 2s are 4, 4m small m upon r square. So I will keep this 4 outside. See over here. So 4 into G into m into small m upon r square. So this is the final expression I got according to the demand of the numerical of the C part. So what I will write now, this expression in the form of words, that force will become 4 times. So this is the way we solve the numerical, no matter whatever they say, that the masses are doubled, that is the distance between the object is doubled, the distance between the object is tripled, the mass of one object is doubled. Accordingly, you keep on changing the expression and then you will get the final expression, and then after getting the final expression, put it in words, and this is the way the numericals are done. Provided the basic thing you should know. What is the basic thing? That is this expression you should know, and in the expression, according to the demand of the numerical, keep on changing, and then you will reach the final expression, put it in words, and the work is done. Am I clear, children? So this is the way to solve the numericals, and you have to be quick in calculation, so your maths should be a little bit strong to solve the numericals, children. It's very, very important. So with this positive note, always keep a smile on your face like this. So smile and the world smiles with you always. So keep smiling, children. So with this, I wind up the session. Keep smiling. We will meet very soon with the coming up videos too. So God bless you and keep on subscribing the channel. Please share with your friends AcadShala link so that you do not stop this chain of sharing. Thank you so much, children. God bless.